In the previous video, we have seen how to calculate the power and modulation index of a single tone AM signal. In today's video, we are going to see how to calculate the power and the effective modulation index of multi-tone AM signal. So as we know that the multi-tone AM signal is nothing but the message signal is having more than a single frequency component. So let us see how to calculate the power of a multi-tone AM signal. So for the multi-tone AM signal, so I am considering for a multi-tone AM modulation, the message signal is having a two frequency components and its expression is given as AM1 cos 2 pi FM1 into T plus AM2 cos 2 pi FM2 into T. Okay, now let us find out what is the time domain expression of an AM signal. As we know that the general expression of AM signal is C of t into 1 plus Ka m of t. So for the multi-tone we have mathematically written the expression of m of t, and here the value of Ka is nothing but 1 by Ac and it is called as amplitude sensitivity, and the C of t is a carrier signal and its mathematical expression is AC cos 2 pi FCT. Okay, now simply substitute the values of C of t, Ka and m of t in S of t expression. Then we get its values AC cos 2 pi FCT into 1 plus Ka is 1 by AC and m of t is AM1 cos 2 pi FM1 into T plus AM2 cos 2 pi FM2 into T. Okay, now do simplification. Then its value is AC cos 2 pi FCT plus now AM1 by AC. So it is the first message signal frequency FM1 amplitude AM1, and the ratio of AM1 by AC is indicated with the first modulation index M1 or mu1. So I can write it as AC cos 2 pi FCT cos 2 pi FM1 into T into AM1 by AC I can write as first modulation index M1 plus second modulation index is ratio of AM2 by AC. Then it is AC into AM2 into cos 2 pi FCT cos 2 pi FM2 into T. Now use the trigonometry formula, that is cos A cos B. We can write it as cos of A plus B plus cos of A minus B by 2. So by using the trigonometry equation we will get finally AC cos 2 pi FCT plus M1 into AC by 2 into cos of 2 pi of FC plus FM1 into T plus cos of 2 pi of FC minus FM1 into T. Okay, so one is upper sideband and lower sideband of signal frequency FM1. Now for the second frequency, that is FM2, I can write using the trigonometry relation as AC into M2 by 2 cos of 2 pi of FC plus FM2 into T plus cos of 2 pi of FC minus FM2 into T. So while finding the time domain expression of a multi-tone AM signal, we have to keep in mind that the frequencies, that is FM1 is always less than FM2 and the amplitude is also less, that is AM1 is less than AM2. So for this expression we have to calculate the power value. Okay, so the same procedure is repeated for the calculation of power for single tone AM signal here also. So for a multi-tone, here what is the first term? The first term is the carrier signal which is having an amplitude AC, and the second term is a sideband which is having an amplitude m1 into AC by 2, and the third one is second sideband which is having an amplitude m2 into AC by 2. So for this I can directly write the total power for a multi-tone AM signal. Okay, so the power for multi-tone AM signal I can write it as a carrier power, so which is AC square amplitude and its value is 2R, and next one is the first sideband power. So here it is having again lower sideband and an upper sideband. So now what is the amplitude? It is m1 into AC by 2. So I can write it as m1 into AC by 2 whole square by 2R. Second amplitude is also same. So it is m1 into AC by 2 whole square by 2R. And the third one is second sideband which is having an amplitude m2 into AC by 2. So it is m2 into AC by 2 whole square by 2R. And the next one is m2 into AC by 2 whole square by 2R. Okay, now do simplification, then we will get. So finally I can write PT as AC square by 2R plus m1 square AC square by 2 square is 4, 4 2s are 8, so it is 8R plus m1 square AC square by 8R plus m2 square AC square by 8R plus m2 square AC square by 8R. Okay, now do simplification and take the common of AC square by 2R. So if I take the common of AC square by 2R, then its value is 1 plus m1 square by 4 plus m1 square by 4 plus m2 square by 4 plus m2 square by 4. So I can write m1 square by 4 plus m1 square by 4 as m1 square by 2. Okay, so it is AC square by 2R into 1 plus m1 square by 2 plus m2 square by 2. So I can write in simplicity, then it is AC square by 2R into 1 plus m1 square plus m2 square by 2. So this is the total power of a multi-tone AM signal, considering that the message signal is having two frequency components. Okay, now we can write the m1 square plus m2 square as mt square. So mt square is equal to m1 square plus m2 square. This mt is nothing but we are calling it as an effective modulation index. So this effective modulation index is defined as the square of sum of individual modulation indices of signal frequency components of modulating signal. Okay, if I substitute the value of m1 square plus m2 square as mt square, then I can get the total power of multi-tone AM signal is AC square by 2R into 1 plus mt square by 2. And here the AC square by 2R is nothing but the carrier power. So finally PT value is equal to PC into 1 plus mt square by 2. Since we have written the value of effective modulation index mt for two message signal frequency components. For example, if there exist n message signal frequency components, so n m of t signal frequency components are present, then the effective modulation index value can be written as m of t is equal to, it is having f1, f2 and so on, fn message signal frequency components. So the effective modulation index mt I can write as square root of m1 square plus m2 square and so on plus mn square, where m1, m2 and so on mn are the individual modulation indices for different message signal frequency components. So this is how we are going to calculate the power and the effective modulation index of multi-tone AM signal. Thank you for watching our videos. Please subscribe to my channel. Stay connected and keep supporting.